Next, let's take it further and actually look at graphing full equations. So graphing an equation is actually graphing all of the solutions of the equation, which I think is actually a pretty interesting idea if you haven't ever thought of it this way. So when you're graphing an equation, you're actually visualizing all the solutions that exist for that equation. So a solution to an equation is just a point on a graph and vice versa. We can graph a few different ways. So there's different strategies for how to graph. I'm just going to talk about a couple of them today. And you'll see that as we go through the course, we may find new and other strategies that we'll use as well. So we're going to start with lines here. And lines are the simplest graphs. So they come from linear equations, and you can see the word line right in there. So their graphs are just lines. We can graph lines by making a table of points, which is one of my favorite strategies, or also by finding the intercepts, so the X and Y intercepts, or a combination of those two strategies. And again, there's different ways to graph as well. We'll see later on in the class that we can also graph lines using slope. So we'll get to that later. I'm just going to do a kind of review and introduction to graphing here that applies to lots of different types of equations, not just lines. Now, a linear equation looks like this. So it's of the form ax plus by equals c. Now, those variables can all be rearranged. We know that things aren't always in that perfect order, but some things that you should notice. A and b are not both 0, so there has to be some sort of variable there. And there's really no exponents other than the exponent of 1. So we don't write the 1 in, but we don't have any squares here or cubes. There's nothing really weird going on, right? There's no dividing by variables or multiplying variables together like x times y, for instance. We don't have that here. You may see fractions, you may see decimals, those are okay, any numbers are fine. But the variables should be their most basic form. So no squares, no cubes, no roots, nothing weird going on with the variables. When you have an equation like that, your graph is going to be the simplest kind. It's just going to be a line. Now we can also find special points when we graph, and these are your intercepts. So the x-intercept is the point where the graph either crosses or touches, depending on the type of graph it is, the x-axis. And to find it, you actually always plug in the value 0 for y. And then we solve and we get a point that looks something like this. So it's a number comma 0. The y-intercept is similar, except for it's the point where the graph crosses or touches the y-axis. We find it by plugging in x equals 0 instead and solving for y, and we get a point that looks like this. So let me show you how to graph this first example. It's just a line. If you look at it, again, the x's and the y's, there's nothing going on here. There's no squaring, there's no cubing, there's no roots. I'm not dividing by x or dividing by y, right? It's pretty straightforward. So something like this is going to be linear. Our graph is just going to be a line. All right, so I'm going to show you how to find the intercepts first, and then I'll show you how to find additional points as well if you need to. So I'm going to start with the x-intercept, and I'm just going to abbreviate that x-int. And for the x-intercept, you're always going to plug in y equals 0. So that is a specific definition. So I take my equation, and then instead of writing in the y value, I'm going to replace it with 0. I like to use parentheses when I plug numbers in. It reminds me when to multiply, right? Because 2y means 2 times y. So I end up with 2 times 0 is 0. So this part goes away, and I just have 5x equals negative 10. And then I solve my equation. I divide both sides by 5, and I have the value x equals negative 2. Now, just don't forget, your points are always of the form x comma y. So here, my x value was negative 2, and the y value I used was 0. So you do want to make sure you have it in the right order. If you find it helpful, you could make a little table as well. So again, our x value is negative 2, and our y value was 0. So that's just another way to stay organized. And now I'm going to go ahead and plot that point. So there is negative 2, 0. Again, I'm just counting by ones here. You can check that by noticing where the 5 is. So that's our point, negative 2, 0. Next, let's do the y-intercept. So for the y-intercept, we always plug in x equals 0. Again, that's not going to change. So I start over, And this time I replaced the x with 0 instead. Now 5 times 0 is just 0, and 0 plus anything, again, doesn't change the problem, right? So this cancels out, and I'm left with positive 2y equals negative 10. I divide both sides by 2, and I get y equals negative 5 here. Again, don't forget your points are always x, y, so our x value is 0, our y value is 5. The order of those points really is important. And again, if you find it easier, you can just organize with a table instead. So my x value is 0. Again, this is my x-axis. This is my y-axis. So I'm right at the center here, and I'm counting down to negative 5. So my second point is there. Now, for graphing lines, you actually only need 2 points. So this would be sufficient, and I could connect those 2 points with a line and be done. If you want to find additional points, you always can, though, to check your work. So what you can do is you could pick any value to plug in. The nice thing about linear equations in general is that they do tend to run through all the points. We do have some exceptions with vertical and horizontal lines we'll talk about, but you can pick anything you want and plug it in and find the resulting value. So I always like to pick things that are easy. So make your life easy. You don't have to pick like x is 1,000 and plug it in, or x is 2.74. Pick something that you think is going to be relatively easy to work with. So if I look at my numbers up here, I'm going to choose x equals 2 to plug in. That seems like a nice, easy number to work with. And when I write it out, I do like to start with what I'm choosing so that I don't forget at the end of the problem. So I'm going to just write that down. I'm going to start over, but this time I'm going to replace x with 2. So 5 times 2 is 10. Now, when you don't plug in 0, you usually have a little bit extra work. So I'm going to solve. I'm going to subtract 10 to both sides using just my regular solving technique here. And I'm going to divide by 2, and I get y equals negative 10 for my final result. Now, don't forget here, again, our values are x, y. So we're looking at 2 comma negative 10 as our point. Or if you're liking this table, you can add it to your table, however you like to stay organized. In math, I find organization is sometimes the biggest issue for students. Writing too small, cramming in their work, not staying organized. So if you're finding you're making a lot of little mistakes, just slow down a little bit, try writing a little bit bigger. I would have a designated notebook for this class, right, for homework and notes and things as well, so that you're not writing things all over the place. And then for my third point, it's going to be 2, negative 10. So let's see, here would be 1, 2, and then I'm going down to negative 10. So there's 5, 6, 7, 8, 9, 10. So my point would be right here. And again, negative 10 is right down this way. And then I can just take a piece of paper if I want. I get some scrap paper out here and connect those points together. And there's my graph. Now, a couple of things I will warn about here. If you pick a different number, you may sometimes get fractions. So if I picked 1 here, then I would have been subtracting 5 from both sides and having a 15 to divide by 2. So if you're graphing by hand and you get a fraction, you can just do your best to estimate on the graph where that point would go. I will warn you that for using my math lab, they don't typically let you graph fractions. So if you pick a number to plug in and you get a fraction result, you may just have to try again. Go back and try a different number until you get something that's going to work. The other thing about my math lab when you're working in it is that for lines, it will only let you graph 2 points. So when I'm doing it by hand, I can graph a 3rd point or a 4th point to check my work, and make sure they're all in a line. But for my math lab, they'll only let you graph 2. So just keep in mind, you haven't done anything wrong if it won't let you graph extra points. And then the final thing you want to watch out for is the strategy. So if your problem just says to graph, then it's your choice. You can use intercepts, or you can just pick regular values to plug in, and you can do anything you want basically, and it will be fine. If it does say specifically to graph by finding the intercepts, then you do have to use that strategy or it will mark you wrong. And that's something that a lot of students make mistakes on, is they don't read the prompts carefully enough in the homework or on the quizzes, and they may be using the wrong strategy. Both are good strategies. They both get you the same answer, but sometimes we want you to practice a certain way. So just make sure you read carefully. And if it does specify the kind of strategy, you want to use that one. If it just says graph, then you have a lot more flexibility in how you choose to graph that problem. All right, so another thing I want to show you here before I go to the next page is how to use some technology to graph. And I'm going to show you two different ways to do it. So the first way, and this is my favorite way, is I like to use what's called Desmos to graph. So they have an app for your phone. They do have it online as well, which is easy to use, and it's free. And it's very intuitive. I think it's pretty straightforward to use. So this is my recommended technology for graphing for you guys, but there are a lot of different ones out there. So I'm going to show you the app on my phone. So I'm on my phone here, and I have an iPhone, but Desmos is very popular. So again, they have lots of different apps for different devices, and they also have it online as well. So I go into Desmos, and you have this screen. And what you can do is you can just type in the equation as it's given to you. So I have a 5, I have x plus 2y, and that's equal to, and then I do have negative 10 here. And then you can see that it graphs it for me, and I can, check my work. Right? Does this look right? And the nice thing with the phone as well is, if you have a touch screen, you can actually tap on those points and they will show them to you. So you can confirm that they are the ones that we got. And of course, it's a touch screen, so you can zoom in and out really easily and see what that graph looks like. So I have the app, but there are similar features that you can use if you use it online instead. And again, it's one of my favorite apps because it's just so intuitive to use, I think. If you have a different graphing tool that you want to use, then that's perfectly fine as well. And I will say that other classes may have different requirements, right? So we are solely online. It does not bother me if you use a technology like Desmos, to do some graphing to check your work. You still need to know how to do it by hand though. If you're relying solely on technology, you are going to lose a lot in this class and not be able to have all the skills that you need. But it's a great strategy to kind of check your work. The other app that I have, and this is for iOS, it's called Graph in Calc 83, or sometimes graph is spelled with an F. It just depends on the version that they have. This one is not free. It's usually around $6. And then for Android, my students sometimes like the one called Graphing Calculator. It's X84, and both of those mimic the TI-8384 calculator as well. Now, if you have a real TI-8384 calculator, then definitely go ahead and use it. I like the app because I always have my phone with me, so I know I always have this on me as well. And of course, at least for the iOS, again, I have iOS, I don't have Android. It's in color and it's touchscreen, so it's just super nice and easy to use. But these do sometimes cost money, so it is not free. One thing I want to note, though, is if you are using the TI-83 calculator, graphing is actually more challenging. You have to have your equations in a y equal form in general to graph. So for instance, something like this, 5x plus 2y equals negative 10. I have to bring the x to the other side first by subtraction. Now, these aren't like terms, so I would just write them next to each other. And then I'd have to divide the whole thing by 2. And don't forget you're dividing both parts by 2. So this becomes negative 5/2 x minus 5. So you do have to be in that form first to graph. So here's what it looks like. So this is my app right here, Graph and Calc 83. And I can go to my y equals feature, and then I can go ahead and, again, it's a touch screen on my phone, so it's kind of nice, and I can just type it in. It does give you the y equals part, so you don't need to touch that at all. I do need to turn it on, though, on the app, so you'll see once I start typing, there you go, it should click on. So you just want to make sure that it's green after you start typing. And we're going to type in negative 5/2 cx. So I'm just putting my 5/2 in parentheses so my calculator is reading it correctly. You do want to make sure you use the negative button and not the subtraction button, or you'll get an error message. Your parentheses are right there, and then my x button is right here. And then I do minus 5. And once I've done that, I can click the graph button, and you can see there is my graph. Ignore the circle. I was playing around with that earlier. And you can see, again, it is a touch screen, so it is kind of nice if you have the app Whereas on the standard calculator, you'll have to use the trace button instead to find those points. But again, this is a nice app too. Desmos tends to be my favorite because it's just so much more intuitive, and you don't have to solve things. So that's my tip for using technology here. Let me do a couple more graphing examples with you guys. So here we do have some special lines, and these are graphing vertical and horizontal lines. So they're still lines, but they look a little bit different. And you'll notice that they're sort of missing a variable. So those are your special lines. So this first style right here, this is a vertical line. Your vertical lines always look like x equals some number. So you're gonna notice there's no y variable. And your vertical lines go up, down. Now to graph them, don't overthink them. So literally find the value of -5 on the x-axis. So here's my x-axis. I find -5. I put a point right there. So the point that I have there is, -5, 0. And then I just draw a vertical line right through it. That's it. If you're in my math lab, you do still have to give it 2 points. So I usually will give this one and then pick any point right above or below it. So for instance, if you pick this point, my math lab is nice. You can just kind of click the values, then it will draw that vertical line for you. What you want to notice with these lines is that it doesn't matter which point you pick, the x value is always -5. So that's kind of where it comes from. The other style is your y equal line. And these are going to be horizontal. So horizontal lines go left to right, and they're always of the form, again, y equals some number. So you're going to notice that there's no x there. So what I do instead is I find the value of y equals 3. Here's my y-axis. So 1, 2, 3 is right here. And then I just draw a horizontal line. So that should be perfectly straight right through it. And again, in my math lab, you'll have to give it 2 points. So this point here is the point 0, 3. And then I'd give it another one. Maybe I'll give it this one, which is 5, 3. But any other point that gives you that horizontal line would be sufficient. And again, what you'll notice there is that the y values are always 3. So that value is staying consistent for the whole thing. If you ever see an example that looks a little bit different, for instance, if I had something like y minus 4 equals 2, and it says to graph, what you could do is you can always clean things up. So for instance, I could add that 4 to both sides and get y equals 6, and hopefully now recognize that, oh, hey, this is a horizontal line. It just wasn't cleaned up. So sometimes that does occur, although it is kind of rare, but it's just worth watching out for if you have a graphing example that looks a little bit different, but is still missing a variable. Now, the other example I'm going to show you here for graphing, and again, of course, there's lots more examples that you can review, but just that same general procedure of let's go ahead and just practice finding points and plotting them. This problem is more complicated. Notice that you have a square here, so it's not going to be a line. Anything that's not a line is going to be more complicated. So it's going to be some sort of curve or maybe a V shape or a U shape, but it's going to be more complicated. So when that happens, you may need to find more points. You'll definitely need more than just 2. So I like to set up a table here, again, to help me stay organized. And I'm just going to pick a bunch of values to plug in. Now I'm going to notice that I'm in the form y equals. So what would make my life easier is to pick x values. If I pick x values, then I'm just plugging in and simplifying. If I pick a y value, it's not wrong, but now I have to deal with solving for an x squared, which is really quite difficult sometimes. So again, make your life easy. If it just says graph, doesn't tell me how I have to graph, then you can pick points and pick ones that are easy for you. So I like to pick some positives and some negatives. So I'm going to start by picking x equals -2. And I'm going to go ahead and just replace all my x's with -2. Sorry, that should be a -1, not a +1. And be careful here, don't forget, order of operations says exponents come first. So -2 squared is -2 times -2, which is +4. So this becomes y equals 2 times 4 plus 4 times -2 minus 1. Now I do multiplication. 2 times 4 is 8. 4 times -2 is -8 minus 1. And now I add and subtract from left to right to get -1. So my x value is -2. My y value was -1. And that's my first point. I'm going to do another point. I'm going to do -1. And again, don't forget you do your exponent first. So -1 squared is going to be -1 times -1, which is +1. Square there. And then 2 times 1 is 2. 4 times -1 is -4 minus 1. And again, I add or subtract from left to right. 2 minus 4 is -2, minus 1 is negative. So I have -1, -3. Now, if you have something more complicated than a line, I would probably recommend at least 5 points to start. Again, unless there's restrictions or something, you can do negatives and positives. So this is a good time to pause the video and try a couple on your own. So the other values that I plug in that I checked were 0. So I plugged in x is 0, and I got the value -1. I plugged in x is +1. And when I did that, I got the value of, 5. I plugged in +2, and I got the value of 15. So those are ones that you can check and practice on your own. And now I'm going to stop for a second and kind of plot and see what I have. So I have -2, -1, -1, -1, 2, 3, 0, -1, 1, 5. And now 215 is going to be way off. So here's 5, 6, 7, 8, 9, 10. I don't know, maybe somewhere up here, right? It's off my grid. If I was plotting in my math lab, I wouldn't be able to use that point. So it kind of looks like I have a check mark here for a second. So I'm going to choose one more point because I'd like to know what's happening a little bit more on the left side. I have, 1, 2, 3 points on the right, but I only have 1 on the left side kind of heading upward. So I'm going to also plug in -3. And again, try that one at home. If you plug in -3, you should get +5. And I see this point. So now I'm starting to see the pattern. It seems like I have this mirror image, and that's correct. So these kind of graphs where you have just a square as your highest power are these U-shaped graphs. We call them quadratics, and we'll learn later in the course a more systematic way to graph them. But for now, if you have any graph, you can always use the strategy of just picking values and plugging them in, but you may need a whole lot of points. So I would not just do a couple. I would probably do at least 5. Here I needed 6. I've done some where I've needed 8 or 10 points to actually see the pattern, and that's okay. So here's our graph. And again, this was a little bit more complicated one, so this could be a good one to check. I'm going to use Desmos because that is my favorite app. So, and I'm just going to go ahead and type in the equation as it is. So I have y equals 2x, and I see a little square button right there, plus 4x minus 1. And then I can look and see, okay, does this graph match what I did? Yeah, that looks pretty good. I can, again, even tap and kind of check some of those points. -1, -3, yep, I had that one. I didn't do this one, so I can't check that one, but you can kind of check a few different points and see if there's any that match what you did, and see if you're getting the same answer. So this looks good, and I think I did a pretty good job graphing. Again, if you like, you can try out some other graphing calculators, and I'm happy to help you as well offline. So if you have a different calculator and you're getting stuck, let me know. Again, Desmos is my favorite. I swear I don't get paid from them or anything. It's totally free. I just love it. It's just so easy to use, and I love that it's free. So give it a try.